Okay, so this is the last set of notes on the cross product, and we're going to just bring out a tool in a common calculation that's used with a cross product and a dot product together. And this thing is what we call a triple product. Okay, so the triple product is when you take one vector and you dot it with a cross product. Okay, so this is kind of a unique configuration, but if you're kind of thinking about this in a particular way, it has a kind of unique application, or several unique applications that are useful here. The cross product ultimately kind of yields a somewhat of a vision of an area. Okay, and when you dot that with a vector going in a particular direction, you end up with an idea of a volume. Okay, now I'm kind of hand-waving at this and doing this in a bit of a sketchy type way, but I want to not get too down into the details here. So this gives me a way to consider a volume. So one of the big applications of this triple product is actually finding the volume of what's called a parallelepiped. Okay, so that's a lot of words. A parallelepiped is basically something that has a parallelogram as its base, and each of its faces is also a parallelogram. So you kind of see this as like a prism that's been pushed over from the top. And what can happen here is you can describe a parallelepiped using three vectors. You can have a vector here and a vector here, so let's call this B, and we're going to call this one C. And then you've got a third vector coming up here, which is, we'll call that A. Okay, so if I can use those three vectors, A, B, and C, so A, B, and C in 3 space, I actually know the shape of this parallelepiped. Okay, so how do I find its volume? Well, lo and behold, if I take the triple product, vector A times B times C, okay, so that, and I take its absolute value, I get that the volume is the absolute value of vector A dot B cross C. So this thing actually becomes a volume formula for this. Now, you can spend some time and try to prove that out for yourself, and I'm sure there's some resources online for that. But basically, because you're envisioning this as the area of the base, and A as the slant height coming upward, I'm getting the idea of the volume of the parallelepiped. Okay, so let's actually play this out. Let's say that I have a point here at the origin, 0, 0, 0. I have another point over here at 0, 5, 0. I have a point coming back here at negative 3, 0, 0, and then I'm going up, right? And I am now at, let's say, negative 1. Let's make this 1, 4. Okay. So now I have kind of used a bunch of points, and if you think about this in the right way, you now have determined the base, right? We have determined the front, we've determined the top, and the back of a parallelepiped. So now the question is, what is the volume of this, right? So let's call this vector A, let's call this vector C, and we'll call this vector B. So vector A is going to be the vector -1, 1, 4, right? Vector B will be the vector 0, 5, 0, right? So these vectors are going in this direction. And the vector C is going to be -3, 0, 0. Okay, so I've inadvertently made the bottom a rectangle. That's it's okay. We'll work with it. Okay, so we'll kind of MATLAB a little bit here to see how this works out. So ultimately, I want to find A dot B cross C. So let's see what's going on here. Okay, so I'm now in MATLAB. I'm going to put in my 3 vector values, right? So A is going in as -1, 1, 4. B is going in as 0, 5, 0. And C is going in as -3, 0, 0. Okay, so what happens here? What happens if I take the cross? So let's call this base. Base is going to be the cross product of B and C. Okay, so that gives me a new vector, 0, 0, 15. Aha! So this is like kind of giving you an idea of what I meant by area here. So I do have a vector, and there's a sense of area going on here. Now, had this not been a rectangle, that would not have been that clear. But because it is a rectangle, the cross product is clearly giving me that 15. Okay, so what do I need to finish my volume? Volume should be, well, let's see, A dot the base, right? So it's going to be dot A comma base. And if I take that, I just got 60, okay, which gives me now the volume of that parallelepiped, 60 units. Now it's possible for the V to come out as negative here, so that's why you have the absolute value in the formula. But MATLAB did its job. Okay, so this was just a brief video to get you to see that there is this thing called the triple product. It is a vector dotted with a cross product. This also showed up in our properties list. It's a little bit odd the way it behaves in that list, but it's there. And one of the immediate applications of this is that if I have 3 vectors with a common endpoint and they form the sides of a parallelepiped, then finding the volume of this is to take the absolute value of that triple product.